My name is Demanjit Mahata and I am a research scientist working at Bloomberg, New York. I work in the area of natural language processing. This presentation is about our work, keyphrase extractions from scholarly articles as sequence leveling using contextualized embeddings. This is a joint work with other researchers from Bloomberg, NUS, Adobe and Vedas Labs at IIIT Delhi, India. Keyphrase extraction is the process of selecting phrases that capture the most salient topics in the body of a document. For example, as you can see in the slide, that there is an excerpt from the text of the abstract of a paper. Applying our model on this selects the phrases that aptly describes and summarizes the work. Key phrases have proved to be an important piece of metadata used in various downstream tasks such as text classification, clustering, summarization, and many other areas of information retrieval. The different approaches of automatic extraction of key phrases from text can be broadly categorized into supervised and unsupervised techniques. The supervised approaches mainly consider this task as a binary classification problem where a classifier is trained on a dataset in which humans have already identified and annotated the key phrases. The supervised techniques have been developed for both key phrase extraction and generation tasks, where extraction deals with identifying phrases from the given text and generation has the ability to generate phrases that are not mentioned in the input text. The unsupervised techniques are mostly graph-based models leveraging the PageRank algorithm to rank the phrases extracted from the input text. In this work, we focus on key phrase extraction and not generation and devise a supervised technique. Most of the current techniques suffer from various drawbacks, especially in the processes applied to the input text in order to generate the candidate key phrases. These processes depend on other processes or steps such as NER, pause tagging, and they also sometimes depend on external knowledge bases such as Wikipedia. They also involve too many complex heuristics, which makes it hard for other researchers to reproduce results using an unified process. This motivated us to approach the task of key phrase extraction as a sequence tagging task where each token in the document is tagged as being a part of a key phrase or not, using the popularly used BIO tagging scheme. This formulation has several advantages over the other methods. First of all, it does not rely a lot on heuristics and different text preprocessing schemes. Then it is a unified process resulting in an optimal assignment of key phrases that leverages techniques of other sequence leveling tasks. It also allows us to capture long-term dependencies in the input text. We model our sequence leveling task using the BLSTM-CRF architecture and use the state-of-the-art deep contextual language models, as well as fixed embedding models such as word-to-vec, fast text, and glove for representing words in the input text. We evaluate our trained models on three benchmark datasets, SemiVal 2010, InSpec, and SemiVal 2017. We didn't have to process SemiVal 2017 dataset for sequence leveling. The other two datasets had to be pre-processed, in which we first filtered out the abstractive key phrases from the annotations and only kept the extractive ones. After that, we identified the extractive key phrases from the text in an automated way and tagged the tokens of the text according to the BIO tagging scheme. We only used the abstracts from the SemiVal 2010 dataset. For details of the experimental settings, please feel free to consult the paper. And for reproducibility of the experiments, we have made the process data publicly available in GitHub in the following link. In our exploratory set of experiments, we first experimented different embedding models with BLSTM and BLSTM-CRF architectures and observed that BLSTM-CRF architectures was almost always performing better than BLSTM. The table in the slide presents the top 3 results, which were obtained using Scibert, BERT, and Elmo. We concluded that CRF layers improves the performance for all datasets irrespective of the underlying embeddings, as already observed in other sequence tagging experiments before this. Next, we report the performance of the BLSTM-CRF architecture with different embedding models. Overall, the contextual embeddings perform better than the fixed embeddings, with the BERT family of models displaying best performances, with Robata performing the best on InSpec, Scibert on SemiVal 2010, and BERT on SemiVal 2017. Fast text was the best model among the fixed embeddings. Cybert consistently performed well on all the datasets. Slight better performance of Cybert over BERT could possibly be attributed to the similarity of the scientific domain on which the Cybert model was trained. As we can see from the example in the slide, where phrases highlighted with green are rightly identified key phrases by our model, and those highlighted in the red are wrongly identified ones. Using Cybert, the model tends to identify domain-specific key phrases such as symlib, object-oriented version, more accurately than when using BERT. Apart from using pre-trained BERT and Cybert as an embedding layer in the BLSTM-CRF architecture, we also fine-tune these contextual language models by adding a fully connected layer as the last layer. The BLSTM-CRF architecture performed better than the fine-tuning experiments. Our best models also outperformed the many popularly used baseline models such as SGRank, Single Rank, TextRank, and Kia. We also conducted a short study on the attention patterns of different layers in BERT and Cybert using the BERT-Viz tool. Due to lack of time, I would skip this and would request the listeners to consult our paper where we have documented our observations. We have still a lot of work to do. This slide lists the future work that we envision to do in the future. Thank you. Thank you for listening. For more questions, please feel free to contact me at dmahata@bloomberg.net, and you can always go and consult the preprint version of this paper already available in archive. Thanks a lot.